Well, hello, VEST scholars. Welcome to Module 4, and specifically Module 4's lab. This is Russ Kors, your host for the lab video here, and I'm going to talk to you about the lab specifically. And really, this lab, while the module itself focuses on the entire atmospheric column, this lab is really focused on ground level production of ozone and nitrogen dioxide and other related NOx gases. Ozone in the atmosphere, in the stratosphere, is very easy to make. You just need ultraviolet light at low wavelengths, and we have plenty of that in the stratosphere. Of course, the ozone itself blocks some of those wavelengths of light, some of the short ones, from making their way down to the troposphere. So technically speaking, it's actually quite difficult to make ozone in the troposphere because of the absorption of that radiation by the creation of ozone in the stratosphere. Now, ozone itself is a secondary pollutant in the troposphere, and it generally exists in very low quantities, except during certain times and certain places and so forth, and largely as a result of human activity. So, to produce tropospheric ozone, you have to take certain groups of gases, volatile organic compounds, non-methane hydrocarbons, carbon monoxide, and combine them with hydroxyl radicals and so forth. And eventually you can produce, through the emissions of some of the longer wavelength UV radiation, you can then break apart those NOx gases to produce free oxygens, which then combine with O2 to produce ozone. So here's an example of that. Stage one, of course, is the accumulation of pollutants in the lower troposphere below the inversion layer that occurs during the daylight hours. Talked about in the earlier video. You take your NOx gases, your carbon monoxide, and your VOCs, all emitted by tailpipes, power plants, and so forth, and then you subject them to sunlight. The sunlight in UV radiation wavelengths, and that effectively breaks. You turn NO2 into, or you break an oxygen off of the NOx gases, and you end up with NO, and of course that oxygen then combines with O2 to produce ozone. And then that ozone does a couple of things. It can be deposited on plant surfaces and in the ground. It can go up into the upper troposphere, and it moves around. It gets cycled around within the troposphere, but below the inversion layer, looked at in this screen, of course, that's what's creating your photochemical haze. We say photochemical again because you're producing this chemical via sunlight, so it's photochemically produced, but it would not be produced in these kinds of quantities and very easily without the tailpipe emissions that come from the burning of hydrocarbons, gasoline specifically, gasoline and diesel. So again, this is kind of looking at also the quantities in teragrams per year. This is a lot of ozone being produced and exchanged. So here you're looking at gas exchange of ozone. Some of it gets deposited into the system on the surface. Other ozone gets emitted back into the stratosphere, and some of it stays in the troposphere. Of course, ozone can then also be broken apart again to make O2 and then have oxygen recombine with the NOx gases. So there's also a reverse set of processes that are going on, and that's what's going on here. You have the production of ozone, and then of course this is also cyclical, so you have the destruction of ozone as well under certain conditions. Bottom line is, though, you have the right conditions, the right chemistry in the troposphere with human activity to produce ozone. So you end up with certain effects. Of course, photochemical reactions are most intense during times when the sunlight is most intense. And of course, be thinking about things like this now. When is the sunlight and the radiation from the sun and the heat and all that most intense? During the day and during the year. And those are some of the questions you should be asking yourselves as you look at data like this, taken from a station in Hungary, where they were looking at ozone on half-hour averaged concentrations. So here's 3 years, 1996, 97, and 98, and you can see, at least for this station, after the noon hour, generally between 12 and 4 o'clock in the afternoon, you would have your highest ozone concentrations. So, of course, during looking at the monthly concentrations, the middle of the year during the summer, you would also get the highest concentrations. And for this station anyway, 1996 wasn't so bad. It must have been of course, weather and climate in any given year can affect how bad the ozone concentrations get. But you can see there is variation from year to year. But generally speaking, you can make a prediction about that ground level ozone. Now, if you have stations that are above that inversion layer, they may behave differently. That's something to consider. So whether are you collecting ozone data from above or below the inversion layer? So these are important questions to ask yourself as you go through the lab. And be sure to refer back to these videos, but really study the graphs you're given before you start answering the questions. Make sure you answer the questions in complete sentences, but study the graphs, both the ozone and the NOx gas graphs, and I think you'll come to some really interesting conclusions. But have fun learning. Till next time.